Good day. Welcome to another series of Mathematics Just Got Easier with the Tutors. In today's class, we are going to be considering root 3 and root 4 of cycle geometry. So we have root 3 and root 4 on the board. Root 3 says a triangle formed by two radii is isosceles. We know that a radius is from the center of the cycle to the end of the cycle, to the other end of the cycle. And when we say isosceles, isosceles triangle is a triangle that has two sides to be equal. So let's try to get a better understanding of this. So a triangle formed by two radii is isosceles. Let's see. Now, from here to here is a radii. From here to here is also a radii. So we have this triangle. Let me say triangle A, B, C. So triangle A, B, C is isosceles. Likewise, we have another radii. From here to here is a radii. And from here to here is a radii. Then another triangle is formed. So I like to say AD. So triangle ADC is isosceles, meaning this angle is equal to this angle. So when we say a triangle formed by two radii is isosceles, we mean that you have a radii forming two radii forming a triangle, two radii forming a triangle. And I don't want you to get it confused, because some people might be looking at that from the point of the center of the cycle, that this is a diameter. Remember that a diameter is made up of two radius. So that is why we have here as a radii, from the center to the end, a radii, from the center to the end, a radii. And also from the center here to the end, we also have a radii. So that's how we come about root 3, a triangle formed by two radii is isosceles. Let's move on to rule 4. Rule 4 simply says that a diameter bisects a chord. What is a diameter? A diameter is a line that passes through the center of the cycle, and it runs from one end to the other, and it passes through the center. And it bisects a chord. This is a chord. That's why I labeled it. This is a chord at right angle. So you have this diameter bisecting this chord. So this is a diameter, and it bisects this chord. So it bisects this chord at right angle. So here you have angle 90. So a diameter bisects a chord at right angle. So any chord which is a perpendicular bisector. What is a perpendicular bisector? Because you can also consider the diameter as a chord, and it is actually bisecting this other chord here. So any chord which is a perpendicular bisector of another chord must be a diameter. So here is a chord bisecting another chord is what? And this one is a diameter. Why is this one considered a diameter and this one is not considered a diameter? This one is considered a diameter because it passes through the center, and it is actually bisecting this what? This chord is a perpendicular bisector of another chord. Thank you for listening. In the next class, we are going to be applying these rules. Bye.